about the product and quotient rule. So we'll start with the product rule. And unsurprisingly, it's related to derivatives, and it's exactly what you would expect. It's when you have a function f and g, and you multiply them together, and then you want to take the derivative of that whole thing. What do you get? Well, you get f prime g plus f times g prime. And quotient rule, again, unsurprisingly, is when you want to divide. Let me write that q better. Q. Okay. And the quotient rule, unsurprisingly, is when you want to divide two functions and then take their derivative. And this is a bit more unexpected. Like, you wouldn't really expect this formula, but it is true. And again, I won't give a proof of it, but I will show how it works. So if you want to take that derivative, that is equal to, I think this is it. Yeah, this should be correct because it's easy to get confused here. So you can see this is the exact same, but then a subtraction sign instead. And then all of that divided by g squared. Let me just make a note. F and g are just functions. Any functions of x. That's it. So let's look at the quotient rule first, actually. And let me show you why the derivative of tan of x is equal to the secant squared of x. Let's see why that's true, because I did promise we will see it in one of the videos. The derivative of tan of x. So that's the same as taking the derivative of sine of x divided by the cosine of x, right? That's pretty simple. Well, we can use the quotient rule now. So the quotient rule says f over g. So f in our case is sine, g in our case is cosine. So we do f prime times g. So f prime is just the derivative of sine, which is cosine. So that's cosine of x times g, which is cosine of x. So that becomes cosine squared of x, minus f, which is just sine of x, times g prime, which is derivative of cosine, which is negative sine. So this is sine times negative sine of x, is in brackets, and then divided by g squared. So that's basically cosine squared of x. Well, you can see you have a negative and a negative, so that becomes a positive. So then you basically get cosine squared of x plus sine squared of x divided by cosine squared of x. Well, we know cosine squared of x plus sine squared of x is equal to 1. That's a very famous identity that you should know. And then 1 divided by cosine squared of x, well, we know that's the same as 1 divided by cosine of x all squared, because 1 squared is just still 1, and that is equal to the secant of x all squared. Secant of x is just 1 over cosine x, and this is equal to secant squared of x. So that means that the derivative, we started at the derivative of tan of x. That means the derivative of the tan of x, or the tangent of x if you want, is equal to secant squared of x. And that's why this is true. I did mention this in one of the videos, I think in the chain rule video, and now you can see when you use the quotient rule, this turns out to be true. Now let's do the easy one. Let's do a product rule example. So let's say we had to find the turning points. So find the turning points of y is equal to, let's make it difficult. Let's make it 2 sine 2x cosine 2x for x between 0 and 180. Well, 180 is just pi. Let's work in radians. So that's between 0 and pi radians. Let's find the answer of that. Let's find the turning points. Turning point, and then s, just in case there's more than one. So, well, we use the product rule again, right? So we have that 2 in front. We don't really care about the constant 2. So that's 2. And then we take the derivative of sine 2x times cosine 2x. Well, if you remember from this slide right here, you take the derivative of the first function multiplied by the second function, and then you add that to the first function times the derivative of the second function. Well, then you have, so let's take the derivative of sine 2x first, that's 2 cos 2x. And then you multiply that by cosine 2x, that becomes 2 cosine squared 2x. And then you add that to sine 2x times the derivative of cosine 2x, which is negative 2 sine 2x. I covered these derivatives in our trig and chain rule video, so you should go watch that if you don't understand what's going on over here. So you get that, and then that big 2 is just outside. Well, if you're finding turning points, then the derivative must equal to 0, right? This is dy by dx. And since it's a turning point, it should equal to 0. Well, we can get rid of the 2 because 0 divided by 2 is just 0. So now we have 2 cosine squared of 2x minus 2 sine squared of 2x is equal to 0. Well, we can factorize the 2 again, so we have another extra 2. So you're left with, and cosine squared 2x is actually equal to 1 minus sine squared 2x, because sine squared plus cosine squared equals 1. So you're left with 1 minus sine squared 2x minus sine squared 2x is equal to 0. You can bring the sine squared 2x to the other side, so you're left with 1 is equal to 2 times sine squared 2x. Now this is pretty simple to solve, so you're left with a half is equal to sine squared 2x. If you take the square root of both sides, then you're left with the sine of 2x is equal to plus or minus, of course, root 2 over 2. Let's write that better. Plus or minus square root of 2 all divided by 2. Well, take the sine inverse on both sides, so you're left with sine inverse of the sine of 2x, which is just 2x, is equal to, well, let's use a calculator, right? So we're working in radians, so root 2 over 2. If you take the sine inverse of that, you should get a couple angles. What I got in my notebook is you should get pi over 4. That's one of the angles. And then you should get 3 pi over 4. That's the other angle. You should get negative pi over 4. You should get negative 3 pi over 4. And you should get 9 pi over 4. And so on and so forth. But I'll tell you, we have negative pi over 4 and negative 3 pi over 4. And those aren't in our domain between 0 to pi. But if you have negative pi over 4 as one of the answers, then we have negative pi over 4 plus 2 pi as one of the answers. And we also have negative 3 pi over 4 plus 2 pi as one of the answers. This is equal to 2x. So we actually will have 4 answers in our domain. So we have x is equal to, well, pi over 4 divided by 2 is pi over 8. 3 pi over 4 divided by 2 is 3 pi over 8. And then negative pi over 4 plus 2 pi is actually 7 pi over 4 divided by 2 is going to be 7 pi divided by 8. And negative 3 pi over 4 plus 2 pi should be 5 pi over 4. And then divided by 2 would be 5 pi over 8. So we have 4 turning points. We have pi over 8. And you can put these numbers back into y is equal to 2 sine 2x cos 2x. And you'll get these numbers. And I'll also put a graph up if I can edit properly. And it will show you that these are the correct values for y, for the turning points. So you have 3 pi over 8, and you have negative 1. Then you have 5 pi over 8, and you have positive 1 again. And you're going to have 7 pi over 8, and negative 1 again. So those are our 4 turning points for y is equal to 2 sine 2x cos 2x. Alright, let's do an example question. So the diagram shows the curve of the equation y is equal to e to the negative a half x times x squared minus 5x plus 4. The curve crosses the x-axis at the points A and B and has a maximum point C. Find the exact gradient of the curve at B. That's part A. Okay, that's not that bad. So let's find the coordinate of B first before we find the gradient. So the curve intersects the x-axis at 2 points, at A and B. That means at that point y is equal to 0. So 0 is equal to e to the negative x over 2 times x squared minus 5x plus 4, right? Well, this has no solutions. If this is equal to 0, there's no solution, so we don't need to worry about that. And you'll see that why in the logarithms video. So now you're left with x squared minus 5x plus 4 is equal to 0. You can factorize this. You can have x minus 4 times x minus 1 is equal to 0. So either x is 1 or x is 4. Well, you can see it crosses the x-axis at 2 points, at 1 and 4. And obviously 1 comes before 4, so A has to be the point 1. So A is actually 1, and B is 4. And we have to find the exact gradient. So to find the gradient, we just take the derivative, right? So we find dy by dx. And you can see this is a product of two functions. If we let f, let's do it on the side. If we let f equal e to the negative a half x, and g equal x squared minus 5x plus 4, well, then you're taking the derivative of a product of two functions. Well, we know what we do. We take the derivative of the first function, so we take the derivative of that, which is negative a half times e to the negative x over 2, and we just multiply it by whatever the other function is, so just x squared minus 5x plus 4, and then we add that to, we leave the first function however it is, so it's e to the negative x over 2, times the derivative of the second function, which is just 2x minus 5. This is using the power rule, of course. Well, you can see e to the negative x over 2 is common in both of these terms. So we have e to the negative x over 2. You can factorize that. And then you have negative x squared over 2. Just bring the negative a half inside here. So then you have plus 5x over 2 minus 2 plus, I'm just doing 1 times 2x minus 5, so you're left with 2x minus 5. And we have to find the gradient where x is equal to 4. So you're left with e to the power negative 4 over 2 is negative 2 times negative 4 squared over 2 is negative 8 plus 20 divided by 2 is 10 minus 2 plus 2 times 4 is 8 minus 5. And that is just 3 e to the negative 2, which is equal to 3 divided by e squared. And that's the gradient of this curve at point B. Find the exact coordinates of C. So we're told here that has a maximum point at C. Here, it has a maximum point. But we have to also remember, if we just find the derivative of this and calculate the turning points, we'll also get a value over here. But we don't need this value. We do not need this value right here. So we have to make sure we're careful about that. So to find the exact coordinates of C, well, we just take the derivative again. We don't even have to. We already have the derivative. It's just equal to this, right? We already found the derivative. So we have e to the negative x over 2 times negative x squared over 2 to plus 5x over 2. Yep, plus 5x over 2 minus 2 plus 2x minus 5. Minus 2 plus 2x minus 5. And this is equal to 0 because we're finding a turning point. Well, once again, let's see that this bracket is equal to 0 or this is equal to 0. Well, this is never equal to 0. Again, in the logarithms video, you will see why. So you're left with negative x squared over 2 plus 5x over 2 plus 2x, and then minus 2 minus 5 is minus 7 equals 0. Well, we can multiply both sides by 2, so you're left with negative x squared plus 5x plus 4x minus 14 is equal to 0. And then you can bring x squared to the other side and everything else to the other side as well, so you're left with x squared minus 9x plus 14 is equal to 0. It's a simple quadratic to solve. You can factorize it. x minus 2, x minus 7 is equal to 0. So x is equal to 2 or x is equal to 7. Now which x do we use? Well, remember, there are 2 points. There's a minimum point right here, and of course that point is 2 because it's between 1 and 4, so that has to be x is equal to 2. So this is actually 2, and that means that we don't really know, but this is definitely 7. It makes sense. It comes after 4, and it looks like if this is 4, then this does look like it would be 7, considering the scale of this curve. So x is equal to 7 is what we have to use. This is important. Well, you just put it back into the function right here. So you're left with the exact coordinates are 7 and e to the negative 7 over 2 times 7 squared is 49. Was it plus 5x? It's minus 5x plus 4. So minus 5 times 7 is 35, and then plus 4, which is equal to 7. And then this is 49 minus 35 plus 4 is 18. So just 18 times e to the power negative 7 over 2. And once again, if I edit it correctly, I will draw this curve, or I will tell the GeoGebra to draw this curve for me, and you will see that this point is actually 7, and then the value of that is 18 times e to the power negative 7 over 2. So yeah, that's the quotient rule and the product rule. Very simple. Just a quick recap. So fg prime is equal to f prime times g plus f times g prime, and f over g prime is equal to f prime g minus f g prime all divided by g squared. So yeah, those are the 2 things you need to know, and you've seen why they can be useful. You can take derivatives of these type of functions now. You can actually take any derivative now. Now you have all the ways to take derivatives. So yeah, apart from like special functions, you should know how to take derivative of any polynomial function at the very least now, no matter how difficult it looks. So yeah, that's the product rule and the quotient rule.